The next topic is significant figure. As discussed above, every measurement involves errors. Thus, the result of measured should be reported in a way that indicate the precision of measurement. Normally, the reported result of measurement is a number that include all digits in the number that are known reliably plus the first digit that is uncertain. The reliable digit plus in the first uncertain digit are known as significant figure or significant digits. Okay, if we say the period of oscillation of a simple pendulum is 1.62 seconds, the digit 1 and 6 are reliable and certain, while the digit 2 is uncertain. Okay, thus generally what is the pi value? We should take 3.14 na? But actually pi value is infinity. This is the what? This is the reliable. Okay, I mean certain. Up to pi infinity, this is uncertain, like that. Thus, measured the value has three significance. The length of an object reported after measurement to be 287.5 centimeter has 4-digit figure. Okay, the digits 2, 8, 7 are certain, while the digit 5 is uncertain. Clearly, reporting the result of measurement that includes more digits than the significant figure is superfluous and also misleading, since it gives a wrong idea about the precision of measurement. The rules of determining the number of significant figures can be understood from the following example. Significant figure indicates, as already mentioned, the precision of the measurement, which depends on least count of the measuring instrument. A choice of change of different unit does not change the number of significant digits or figures in a measurement. This important remark makes most of the following observations here. For example, the length 2.308 centimeter has 4 significant figures. Yes, 4 digits there now, but in different units the same value can be written 0.002308 or 23.08 millimeter or 23080 micrometer. All the numbers have the same number significant figure 2308, namely 4. This shows that the location of decimal point of no consequence in determining the number of significant figures. Okay, there is a chance to frame an assertion reasoning question here. All the non-zero digits are significant. So 1, 2 up to 9. These are non-zero. These are significant only all the time. Okay, all the zeros between non-zero digits are significant, no matter where the decimal point if it is. Okay, now these all are significant only. 1, 2, 3, 4, 5, 6. These are before 1. If you put before 1, these are non-significant, but after the number, these are significant only. If the number is less than 1, the 0 on the right of the decimal point, but to the left of the first non-zero digit are non-significant. Yes, no, just now I said. Before the decimal point, these are non-significant. Okay, the terminal or trailing 0 is the number without a decimal point or non-significant. So for example, if we have point like this, okay, these are 5 significant figures, but if we have like this, we have only 3 significant figures. Quite interesting to know this point. Okay, the 0 being not significant. However, you can also see the next observation. The tailoring 0 in a number with a decimal point are significant. Just now I said 3.500. These are very important. Most of the students will confuse here itself only. There can be some confusion regarding the tailoring 0. Suppose a length is reported to be 4.700 meter. It is evident that the 0 here are mentioned to be convey the precision of the measurement and are therefore significant. It could be superficious to write them explicitly. Okay, they given like this one. If anybody wants, they can listen. They can read about that the number has two significant figures. While in the fact it has four significant figures, and may change the unit cannot be changed the number of significant figures. So by changing the units, we can't by changing the units, but we can't change the number of significant figures. Okay, in any unit, the significant figures are, see, observe. To remove some in this we have a lot of confusion now. So to remove such ambiguities in determining the number of significant figures, the best way is to report every measurement in significant notation in the power of 10. Okay, so actually this question, for this question we should get 4 significant figures. Okay, but by changing the conversions, here you are getting only how much? 2 significant figures. This is inconvenient now. So to avoid this, they put the power to the they came with the scientific notation power of 10. In this notation, every number is expressed as a into 10 power b. There a is the number between 1 to 10 and b is any positive or negative exponent or power of 10. In order to get an approximate idea of the number can be expressed as 10 power b, in order which with the exponent of power b of 10 is called order of magnitude of the physical quantity. When only an estimate is required, the quantity is of the order of 10 power b. Here is the example they mention, so you can go through that. Next, okay. Thus, in the scientific notation, no confusion arises about the tail ring 0 is the base number of a. They are always significant. The scientific notation is the idea for reporting measurement, but if this is not adapted, we use the rules adapted in the preceding example. For a number greater than 1 without any decimal, the tail ring 0 are not significant. Okay, for a number with a decimal, the tail ring 0 are significant. So if they had decimal point, they are significant only. The digit 0 conventionally put on the left of a decimal for a number less than 1, like 0.1250, is never significant. This 0 is not significant. However, the 0 at the end of such number of significant measurements. The multiplying or division factor, which are neither rounded number nor number representing measured value, are exact and have infinite number of significant digits. For example, radius is equal to diameter by 2. Okay, so s is equal to 2 pi r na area. The factor 2 is an exact number and it can be written as 2.0 or 2.00 as it required. So this formula we get in gravitation chapter, so please don't confuse. So here decimal is there na, denominator. Here n is the exact number, like here time to find the time period. Rules of arithmetic operation with significant figures. These are somehow important. The rest of calculation involve approximate measured value of quantities, that is, values with limited number of significant figures must reflect the uncertainties in the original measured value. It cannot be more accurate than the original measured value themselves on which the result is based. In general, the final result should not have more significant figure than the original data from which it was obtained. Thus, if mass of an object is measured to be, say, 4.237 gram, 4 significant figure, yes na, and its value is measured to be 2.51 centimeter cube, then its density by arithmetic division, they given some example only. So just go through these examples. Okay, but here if the power is given like this, if the answer like the 3.187 into 10 power 10, here the significant figures, we should not count this 10 power 10, just we should, these are not comes under significant, only these four values are comes under significant figures only for multiplication purpose. That is the overall review. Okay, in addition or subtraction, the final result should, where it is, should written as small decimal places as or there is a number of at least in, for example, for subtraction or addition, if for example, see here, in some 3.03 like this they given, 1.31 like this they given, 1.0 like this given. So the final answer should be two decimals only, two significant figures only. Okay, the final answer should be in two significant figures only. Why? Because the least significant is 2 only, na? In our just example. So the final answer should comes in two significant. That is the conclusion. Rounding off uncertain digits. This is very important. Most of the students will confuse here only. So be careful and have a focus on here. See in your book. The result of computation with approximate number which contain more than one uncertain digit should be rounded off. The rule for rounding off number to be appropriate significant figure are obvious in most cases. A number 2.746 rounded off 3 significant figure is 2.75. Okay, if while the number 2.743 would be rounded off 2.74. Okay, why? Okay, you may get a confusion, but they given a rule, so we will move forward. The rule for convention is that the preceding digit is raised by power 1 if the insignificant digit to be dropped, the underlying digit in this case is more than 5, and the here in this question 2.46, this value is more than 5 na? So that we add plus 1 and we round it as 3 significant figures, whereas another question 2.734 na? We have less than 1 in that, greater than 1 in this, less than 1, so we need to eliminate. Okay, so the significant 3 significant is 2.74 only, up to there only, that's it. But okay, if in case 7.245, this is not less than 5, not greater than 5, then in this situation what we should do? In here only most people will do more and more mistakes. So have a be careful here. Here the convention is that if the preceding digit is even, the insignificant is simply dropped, and if it is the odd, the preceding is raised by 1. So this is even na? 4 is even na? So there is no change. 7.24 is the exact our 3 digit significant figure. If in case like this, if in case it in the question is like this, then the question is round up to 3 digits. This is the hit question. If the question is round up to 3 digits, then the answer is 2.74. Why? Because 3 is odd number, so we should add plus 1. That's enough, nothing more than it. This is highly enough. Okay, and the value of pi is 3.1 up to infinity is known as a large number of significant figures. You may take the value of as okay, the limited number of significant are required in the special cases. So these are some questions they given. Please go through it. Rules for determining the uncertainty in the results of arithmetic calculations. These are also quite important. Okay, these rules also quite important. So the rules for determining the uncertainty in the results of arithmetic calculations. The rules for determining the uncertainty are error in the number or measured quantity in arithmetic operation can be understood from the following examples. If the length and breadth of a thin rectangular sheet are measured using a meter scale, it has 16.2 cm and 10.1 cm respectively. There are three significant figures in each measurement. Okay, yes, now it means the length L may written as they given like this. Simply the breadth 10.1. So that's the error they are taking to examples like this. Okay, don't get confused. Thus the error of product of two or more experiment values using the combination error rule will be, so L into B, length into breadth, so 16.2. Error, this we should add, errors are always added, and we should multiply 16.2 into 16.2, somehow value we get like this. This leads us to quite the final result as L into B is equal to 2.6 now. So this is much more greater than 5 now. So we add plus 1. So our answer is 164 plus or minus 3. Like that we should do. Okay, don't get confused. Just to multiply the values and error, whereas errors errors are always added only. I said errors are always added. Just add the errors and multiply the given answer and take the appropriate. Just now we discussed now if it is greater than 5 what to do, less than 5 what to do, if it is equal to 5 what to do. Just go through it and put it. Pick the right question on our examination. Okay, just all you need is practice. Practice is the only key role plays here. So in our okay, next, if a set of experimental data is specified to n significant figures, as a result obtained by combining the data will also be valid to n significant figures. Okay, however, if the data are subtracted, the number of significant pairs can be reduced. I think you people easily understand. For example, 12.9 grams minus 7.06 gram, both have specified to 3 significant figures, cannot be properly be evaluated as 5.84 grams but only 5.8 grams because 4 is less than 5. That has uncertain in subtraction or addition combined in a different fashion, smaller number of decimal places rather than the number of significance in any of the number added or subtracted. The relative error of a value of number specified to significant figure depends not only on n but also on the number itself. For example, the accuracy in measurement of mass 1.02 gram is plus or minus 0.01. In the same way they given for division, errors should be added. Okay, errors always should be added. Upon this simplifying we get plus or minus 0.1 in percentage there now. So here 9 is greater than 5, so 9.9 we should take and divide this value and into with 100 we get the answer 0.1%. Okay, finally remember that intermediate results in a multi-step competition should be calculated to one more significant figure in every measure than the number of digits in at least in the least precision measurement. These should be justified by the data and then the arithmetic operations may be carried out. Otherwise, rounded error can be built up. For example, the reciprocal of 9.58 calculated after rounding off to the same number of significant figure 3 is 0.104. but the reciprocal of 0.104 calculated to 3 significant figure is 9.62. However, if we had written 1 by 9.58, we get 0.10044, and then take the reciprocal to the 3 significant figure, we would have retired the original value of 9.58. This example justifies the idea to retain one more extra digit than the number of digits in the least precise measurements in intermediate steps of complex multi-step calculation in order to avoid addition error in the process of rounding up the number. Okay, dimensions of physical quantities. Dimensions of physical quantities are quite important. If we see the previous year questions, around or more than 60 to 70% questions from these topics only. Okay, so that much of important. For these topics, ncert content is not at all enough. ncert is give only the guidance, but we should approach. So for these dimensions, how it is, if we cover all the topics now, all the formulas, all the topics, then you will get a better idea. But practice is very important now. So generally in every college material they will give a list, in a table they will give a list around 200 plus formulas. So if you have that, just go through it and try to practice it. Okay, but my job is to give some idea about dimensions, so I will help you here itself. But you should do more practice there. You should do more practice by taking the objective books help. Okay, otherwise no use. I mean, why I am saying do practice, because if you look at the previous year question, they asked mainly on formula only na. So it is easy to you. So if you practice, it is very easy to you. So go through it. But for our theory purpose, I am helping here. So let's come. Dimensions of physical quantities. Okay, what is mean by dimensions? Okay, actually dimensions means these are the parts. Okay, like this. Okay, now this is true now. For example, I will give an example. mLt power minus 2. This minus 2 is nothing but power. Okay, this minus 2 is nothing but power is nothing. This is dimension. Okay, this is dimension. Then what about physical quantity? What is meant by physical quantity? Why? Because these are must, one should know. Physical quantities, it means quantity which can be measured by an instrument which describe physical world. Okay, I think you get the point. So this is the dimensions. While solving the questions, one formula will help you most. Physical quantity is equal to N1 U1 is equal to N2 U2. I mean LHS is equal to RHS. Before entering the topic only, for our basic idea I am explaining here. Here N is equal to numerical. Okay, any numerical that has mentioned in the question, and U is the comparison. U is comparison. Okay, so if you are writing on your ncert, please listen my words and write, because I am helpless to teach you by writing. So please support me and understand my feeling. But if you want to gain it, please do work yourself, so that if you listen and write, it is also very helpful to you. Okay, thank you. Next, so I explained what is meant by dimension. These are the powers to which the fundamental units are raised in order to express the derived unit of quantity. Okay, I said in just before only, m, mass, length, time, these are the fundamental quantities. Okay, fundamental constants. Mostly we use this. There are 7, but mostly we use this. For deriving if they have powers like this, if the powers raised like that, those are called dimension. Those are its dimensions. Okay. I think you get now a clear idea. I hope. Okay. The nature of physical quantity is described by its dimension. All the physical quantity represented by derived units can be expressed in terms of some combining of 7 fundamental or base quantities. We shall call these base quantities as 7 dimensions of physical world that are denoted with square bracket. Thus length, temperature means K, luminous intensity CD, candela, and amount of substance is mole. The dimensions of physical quantities are power. Okay, I said dimensions are exponent to which the base quantity are raised to be represent that quantity. Note that using the square bracket around a quantity means that we are dealing with the dimensions of the quantity. In mechanics, all the physical quantities can be written in terms of dimensions. L, M and T. For example, the volume occupied by an object is expressed as the product of length. Okay. For volume, V is equal to, wait a minute. Okay, for example, volume occupied by an object expressed by product of length, breadth and height. Yes, no? Length, breadth and height, no? In the same way, hence volume is equal to L cube, like that. Okay. For example, area. Area, how we write? Length into breadth, no? So L square, like this. So if they given in volume, we should take length, breadth, height. For area, we should take length into breadth. So for this purpose, L square. For this purpose, L cube. Next, as the volume is independent of mass and time, this is very important. Why? Because actually we know, but if they given in the examination, we do wrong. So whenever these type of important points hit, we should read like a question. Okay, so focus here. That is very important. Most of the people know about it, but they don't know if it came in the exam, they may fail. The reason is this: it is said to be possess 0 dimension in mass m0 and 0 dimension time t0 has 3 dimensions in length. So volume and area, that only depends on length only now. So that is independent of mass and time. Similarly, force, most famous formula, F is equal to ma, right? So mass we know, acceleration is equal to, what is the formula? Acceleration is equal to change in velocity by change in time, na? Okay, next chapter we will come across, but these are some basic formulas, so one should know about it. Change in acceleration by change in time, na? Okay, acceleration is equal to change in velocity by change in time. So change in velocity we measured in meter, change in time second. Okay, velocity is meter per second into change in time also second. So m by s square. So m in change in velocity. Okay, here length. I think you get my point. Okay, see, acceleration is equal to change in velocity by change in time, na? So velocity is nothing but meter per second, meter per second into, here time also second only, na? So velocity we measured in length, so L as usual, t second into second square. If it comes up negative point, we should put, na? But where about mass? No. So we should put in the dimension plus 0. So the dimension formula of acceleration is m0 L1 t power minus 2. Like this, we should write the dimension formula. Okay, easy. the dimensions of force. So ml t power minus 2. Okay na, m into a na, so ml t power minus 2. If you know, it is good, otherwise at least learn now itself. Why? Because without knowing dimension formulas, you may lose a lot of marks. Why? Because the dimension formulas quite important, and okay, in initial days you may get struggle, but for this dimension formula some basics are there na, mass, acceleration, velocity. If you will remember that, so by even very large formulas also we can write dimension formulas, but all these required practice only. So please go to that. Note that in this type of representation the magnitude are not considered. It is the quality of the type of physical quantity that enters. Thus a change of velocity, initial velocity, average speed are all equivalent in this context, since all these quantities can be expressed length by time. So velocity is equal to, just now I said na, meter per second. Most people know meter will be measured in length, and time we speed meter per second is nothing but t, reciprocal 10 inverse. So dimensions of velocity is L t minus 1 m0, like that. And these are some basics, but we should learn dimensional formula and dimensional equations. These are very important. Okay, next, the expression which shows how and which of the base quantities represent the dimensions of a physical quantity is called the dimensional formula of the given physical quantity. For example, the dimension formula of volume is equal to L cube na, so it doesn't depend on mass and doesn't depend on time. This is previous year question, I think in JE. And velocity also we know na. Similarly, the dimension formula of acceleration. Next, density is equal to mass by volume, so m as is 1 by volume L cube na, so it does not depends on time na, so m L minus L to the power of minus t0, like this. One should write the dimension formula like this. Okay, an equation obtained by equating a physical quantity with its dimension formula is called dimensional equation of the physical quantity. Thus the dimension equations are the equations which represent the dimensions of physical quantity in terms of base quantities. For example, the dimension equation of volume V, speed U, force F. These are the representation symbols. Just now we done how to write these formulas like that. Just it's enough. Next, dimension analysis and its applications. These are also very important. Okay, so don't neglect. I hope somehow you get some knowledge about dimensions, but the remaining also very important na? Let's see. Dimension analysis and its application. The recognition of concept of dimensions which guides the description of physical behavior of basic importance, has only those physical quantities can be added or subtracted which has. So these dimensions are like this. Okay, dimensions of each term must be these can be added or subtracted. A thorough understanding of dimension analysis help us in deducing certain relation among different physical quantities and checking their derivation, accuracy and dimensional consistency or homogeneity of various mathematical expressions. When magnitude of two or more physical quantities are multiplied, their units should be treated in the same manner as ordinary algebraic symbol. We can cancel identical unit in the numerator and denominator. Okay, like this. If identical are there na, so we can cancel out. Okay, so that is the ncert trying to explain. The same is true for dimensions of physical quantities. Similarly, physical quantities expressed by symbol of both sides of mathematical equation must be same. From the thermodynamic, the temperature, this is simple principle called principles of homogeneity of dimensions. In an equation, extremely useful in checking the correctness of an equation. If the dimensions of all the terms are not same, the equation is wrong. So if LHS is not equal to RHS, okay, so that the dimension is not correct. Hence, if we derive an expression for length or a distance of an object regardless of the symbol appearing in the original mathematical relation, when all the individual dimensions are simplified, the remaining dimensions must be that of length. Similarly, if we derive an equation of speed, the dimensions just now speed is nothing but velocity only. So just now we did now same thing we need to know. Very important thing one should know here, this is the argument of physical functions such as the trigonometric, logarithm and exponential functions must be dimensionless. For example, we come across this formula p is equal to p naught e power alpha delta t square. If like this is given, if like this came, there is no dimensions. That formula is dimensionless quantity. Okay, this is dimensionless quantity. So this paragraph is very important. Now we can test the dimension consistency or homogeneity of the equation. Here given some example how they whether LHS is equal to RHS. Okay, let's take x is equal to L, x naught is equal to L, v into t is equal to velocity, I mean nothing but speed, L t power 1 into t, we know na. Next into t, half a t square is equal to, okay, half a t square is equal to acceleration meter per second square, L t power minus 2 into t square. Okay, I think you get this point. So by simplifying this, you do just one thing, move x naught and v naught into t this side, then equate. If we equate, we get LHS is equal to RHS. Okay, so this is a dimension quantity. It may be noted that a test of consistency of dimension tells us more and no less than a test of consequency of reality, but has the advantage that we need not commit ourselves to a particular choice of unit, and we need not worry about the conversions among multiplies and sub-multiplies of the unit. It may be borne in mind that if an equation fails this consistency, not proven right, thus a dimensionally correct equation need not to be actually an exact or correct equation, but dimensionally wrong, incorrect or inconsistent equation must be wrong. So here they given one more example. So half mv square is equal to, so for your purpose only, for mass, okay, m we should write, for velocity meter per second, so we should square as it is. For mass, for gravitation, we should learn this, but generally we come across in further chapters. So next, just equate both. Okay, for equate both, then when we equating both, we should get the same formula. So here we are getting the same formula, then it is correct. In the same way, the remaining all, just go through it. Deducing the relation among the physical quantity. Okay, here the formula is n1 u1 is equal to n2 u2. Here the formula is n1 u1 is equal to n2 u2. Apply this and solve such that we will get the answer. Okay, please write in your NCERT before this question formula. These are physical quantity formula. n1 u1 is equal to n2 u2. This is very important. Deducing by using n1 u1, there may be asked in questions like convert 1 Newton to 1 dyne. 1 Newton is SI unit, 1 dyne is CGS. Just now, like that they ask in the examination. So try to solve the questions. That is very important. As it's a theory class, so I am not teaching the problems. If time permits, I will make another video, and by selecting topics related problem definitely I will do in future. But now just complete your theory and make a master in your theory. After becoming good at theory, then we will go to the numericals. Okay. Deducing the relation among the physical quantities. The method of dimensions can sometimes be used to deduce relation among the physical quantities. For this, we should know the dependence of physical quantities on other quantities. Up to 3 physical quantities are linearly independent variable, are considered it has a product type of dependence. Let us take an example. So this is very important question. Okay, this is very important question. Okay, consider a simple pendulum having a bob attached to a string that oscillates under the action of the force of gravity. Suppose the period of oscillation of simple pendulum depends length, mass and acceleration due to gravity is nothing but g. Derive the time period using method of dimension. So k is nothing but constant. It is dimensionless only, so not get worried. X, y, z are the dimensions, are nothing but exponents. So what they given? Okay, what they given? Time. Okay, time period we should calculate now. T is equal to, in which factor they depends? Mass, length. The formula is this: T is equal to 2 pi under root L by G. Okay, mass of the bob. Time period formula is that, but they given that depends on mass, acceleration, length. So time period ante time period is equal L0 M0 T. Ante time period is equal to depends on length na, so it's the power x. Next it depends on what? Acceleration na, so acceleration nothing but meter per second square. So we should write like this. Next mass na, like this. First what about length? Length in x, y, z na, so length only in x and y. So a length put as this and add those powers, x plus 2 into y, 2y na, so like this. There is no mass. T only y only, so put as this. Mass in only z only, so put as this. Then equate. So for length x plus y is equal to 0. Okay, here 0 is there na, so 0. Here length 0 is there na, so 0. So for balancing, next for time they given minus 2y. So t here 1 is there na, so minus 2y is equal to 1. Next, whereas z is there na, here z is nothing but mass. In this mass 0 only. So by equating we get the answer k L power 1 by 2 and g power minus 1 by 2. That is the answer. Very important. Okay, note that the value of constant k cannot be obtained by the method of dimensions. Here it does not matter if some number multiplies the right side of this formula, because that does not affect its dimensions. Actually k is equal to 2 pi, so that t is equal to 2 pi under root of L by G. Dimensions analysis is very useful in deducing the relation among the interdependent physical quantities. However, dimensionless constants cannot be obtained by this method. This method of dimensions can only test the dimension validity but not the exact relationship between physical quantities in any equation. It does not distinguish between the physical quantities having same dimension. A number of exercises at the end of this chapter will help you develop skill in dimensional analysis. Okay, thank you. Thank you for watching my video. Actually, this is my first video in this YouTube. So there is a lot of fear to teach. If any mistakes, please excuse, but try to observe the content what I help you. So okay, don't run the mistakes, just run towards the good thing. So what I so mostly in even YouTube in any coaching institutions, they won't teach line to line NCRT. That is actually students, most of the students required NCRT line to line, because some students not able to understand, some students they can understand, but they are not able to perform it in examinations. So for all those people, students only I kept in mind. I am trying to make videos to help the students, okay, nothing personal. So if you like this, please help me by subscribing our channel. Thank you.